Hello and welcome back to this video. So today we are going to take a look at Java 19 and Project Loom and what it can do for us and help us. But without further ado, let's dive in. So let's first start with the basics. Imagine this is a standard application where we have multiple threads inside our Java virtual machine. The problem is if we have multiple threads inside our Java virtual machine, these threads will eventually end up inside our operating system and then also inside our CPU. So while at the first glance, it might be a good idea to spawn hundreds and hundreds of threads to execute things in parallel, this is not the way it's working. Because imagine, for example, that you have one CPU with one core. What the CPU has to do if you have 10 threads or 4 threads like we have here, it will start the first thread, it will execute it, then suspend, go to the next thread, execute it and suspend, and then will switch 4 times until it goes back to the beginning. So a CPU, like a human, cannot do things in parallel. It can only do it concurrent, meaning it will have to switch between these threads very, very fast. So from the outside, it looks like it's doing things in parallel. This is what we somehow call blocking I/O. So if we start a thread and then wait for data to income, for example, from the database or something else, we will wait there for the data, and this is eventually starting to block the thread, and this is why it's called blocking I/O. So intelligent people in the past thought of other solutions. So what was invented here was the so-called reactive programming model, which was basically not we wait for the data and then read the data. It works basically by the pattern of publish and subscribing. So instead of waiting, we subscribe, for example, to a database. And when the data is there, we will be notified and then can read the data. With this pattern, it is possible for these reactive frameworks to work with only a handful of threads, usually 3. While this can be a solution to the problem, this means a lot of work and cognitive load, as we would say, for the programmer, because in contrast to the usual way of having synchronous coding, we now have to work not only async, but with this publish and subscribe pattern. And while there are good solutions and good APIs to work with this, to have it looking very good on the code side, the point you have to debug this stuff, it can get tough as nails. So yeah. So this imposes a lot of thinking on the programmer. So one step further, we have a model like this, which can be called virtual threads. This is now what we have in Java 19. However, this was not invented by the people behind Java 19. We already had this long time ago in Go. They were called Go routines. And then Kotlin somehow copied this with Kotlin coroutines, not to be, yeah. So what's the idea behind? The idea behind here is that we have some kind of virtual threads. So what the hell is a virtual thread? Good that you ask. So a virtual thread, as you see here, is not directly spawned inside the kernel. So you can have much more virtual threads than you have actual kernel threads. And this will be managed by your application or by your JVM, as we have it in Java. The theory behind is what I explained earlier, this starting, executing, and resuming is now handled by Java itself. So what it will do, it will start your virtual thread, then detect, okay, it's doing nothing, it's waiting. It will put it to sleep, put it inside somewhere in the memory, and then go to the next virtual thread and execute this. And this is all then handled by the Java virtual machine, and only the active threads are then executed inside your operating system. We will see this later in our profiler, what this means. With this pattern and with this very lightweight threads, you can have even 10,000, 100,000 of these virtual threads, because the Java virtual machine takes care for that for you. And the nice thing is you don't have to learn something new like this reactive programming pattern. The API and the way it works is much easier and looks much more like synchronous coding. Okay, one last theoretical thing before we dive into the code. What do we need? So first and foremost, we of course need Java 19. So I'm using Azul 19 here. Please take in mind, this is a so-called preview feature, and JDK 19 is also not a so-called LTS version, but Project Loom will finally hit Java 21, which sounds far away, but Java 21 will arrive at the end of the year. So we will have a stable release for Project Loom at the end of the year that we can leverage. But for taking a look, now it's okay to use Java 19. So we need Java 19, and then we need to tweak our build a little bit. So with Gradle, it works like this. So if we compile our code, if we test our code, and if we execute our code, we have to set this special parameter, which is called enable preview. We also have to set the language level to Java 19. And if you want to build Docker images, of course, your base image needs to be Java 19 as well. And we can see this in zip here. You also need to apply JVM flags, the enable preview here. But with that all done, we are good to go. So let's now start by taking a look into the code. We have this component which is called Loom component, which has multiple methods, which are called doSleep, doFile, and doHTTP, which we will now take a look step by step. And our first method, doSleep, takes a so-called thread count, rounds, which is basically how often we want to execute this, and the virtual flag, Boolean flag, where we can say use virtual threads or don't use virtual threads. So if we execute this with 1000 threads for the first time, so we have to start our Spring Boot application here. Let's see what will happen. So application starts, and this terminates really fast in about 1 second. It also gives you this active threads. This is, however, only working if we are usually using real threads here. So this is really fast. At the end of the day, this is just doing a thread sleep of 1 second. If we now activate Project Loom and we say true, let's see if we can get a difference here. Start, compile, measure the time, and no, it's just as fast as the other one. Not faster, not slower, it's basically the same. Okay, so how can this help us? One of the key differences we can spot immediately if we go back to our normal threads and we say, hey, I want to have 10,000 threads. Let's start. And what the application will now try to do is to spawn 10,000 threads inside our operating system. And you will see it will try that, it will start, but it will crash badly. So at one point, Java will tell, or the operating system will tell, hey, there is not enough resources to do that. Okay. Can we do this with Project Loom and with virtual threads? Sure. We can say, I want 10,000. Let's execute. Remember, yeah, this works. Remember, this will not spawn 10,000 threads inside our operating system. It is even crazier. We can also say 100,000 threads. And this should still work. We should now get 100,000 times an output. So because of this, it takes a little longer. Now takes about 2 seconds. But you see, this has been executed nearly 100,000 times. Okay. So if we want to take a closer look what's going under the hood, I will roll back here my code again, and then I will say do sleep, and we will take a look with this with the profiler. For my profiler, I need to reduce the amount of threads we will execute, otherwise the profiler might crash. So we will change this to 100 threads, but we will say we want to repeat this 1000 times, which is mostly basically, yeah, I have to move my window, indefinitely. So I will now start to profile the application with me being moved away. So this is JProfiler. You could also use Visual VM for this. That's not important. And we will take a look at the thread monitor, thread history, and now the thread monitor. And what we see here, as we started to spawn 100 threads, we will see the 100 threads here, boot threads, and we see they are all waiting. Sure, they are basically just doing thread sleep. Yeah, eventually they might go away and then they will reappear. But in a nutshell, we are seeing that we have 100 threads here spawned in parallel. So let's stop this and let's see if we activate our project Loom. By the way, this just works that instead of a new fixed thread pool executor, as it's called, we have a new virtual thread task executor. It sounds totally complicated. If we would do this by hand, so not use this thread executor, the key difference is only if we would say new thread, or we would say new virtual thread. And that's basically it. Okay, so let's profile that and see the difference. Now with Loom activated. Yeah, and what we see is that we have much less threads, and we now have these so-called carrier threads. So this is what's happening behind the scenes. Project Loom has some kind of reservation, some kind of thread pool. We have up to 10 of these carrier threads, and these carrier threads are real threads. And the threads behind the virtual threads are then spawned, given to the carrier threads, executed, and then paused and getting back. So this is what I explained earlier. But as we see, we don't have these 100 threads. We only have this pool of carrier threads here. Okay, I think this is nice. No big performance gain here. So let's do something different. So I uncomment, and so we will now do file. So do file does not simply do a thread sleep. It will actually read a file, this PDF, which is I think 6 megabytes. And yeah, that's a super secret file because this is a manual of my coffee machine. And it will repeatedly read this. So we will again start by doing this 1000 times. And let's see if we can spot a difference here. So standard example. Application starts. This takes a longer while because you have to imagine this is now reading up to 6 gigabytes of data. And yeah, this takes about 8 seconds. And if we say, okay, I want to have this with virtual threads, again, we just have to set this to true. We see it's not 8 seconds anymore, it's about 2 seconds. So it's much, much faster. We should be able to repeat this. I have to, every time currently I have to do clean here. So can execute this again. And it's again under 2 seconds. So compared to the 8 seconds we saw before, there is a real performance gain here. So with reading the data, this seems to be some kind of sweet spot. However, if we would start to also write the data, we won't be able to spot any difference here. So my read file also has some comments here, which will write the data also to the file system. I will not activate this because then I will have hundreds and hundreds of gigabytes of RAM on my SSD, and this is not a good idea. But the takeaway here is a very important takeaway is Project Loom can help you if you have a lot of threads and there is a lot of thread switching. It will not help you if there is a lot of CPU load inside your threads. So if you have the dream that this can help you to start mining Bitcoins, that's not gonna work. It's really only helping for standard things like reading data from the database or doing I/O from the file system, and if you have a lot of switching there. The moment the CPU load gets very, very high, this is not helping anymore. Okay, so this is for file processing. One last thing to go. Of course, what we usually do in our world is HTTP calls. So what we are now going to do is doing an HTTP call. Let's take a look at this method. So this will just call localhost same name. And the fun part is that this implementation is not only the client side, it's also the server, because so it's basically calling itself because we have a get mapping here. This will just return a string and it will also sleep. We can execute this, but we will at the moment take a look into the profiler. Run, starts, executes, nothing special here. But we will actually increase the rounds here and then take a look what is going on inside our profiler if we start this. Threads, thread monitor, and now what we're going to see, there is a lot of threads now here. So as we are client on server in this example, we have HTTP Neo, which are the server threads, and we have pool, which are our client threads. And you see there is really a lot of them. And our Neo from the Tomcat server in the background are already going into a blocking state, as we might see here. Okay, that's not good. And this is what can happen in production if we will start spawning too much threads, but our system is not able to scale at the same amount. So we are going to stop and we will see if we can optimize this. So we will now activate Project Loom. So we will now start spawning virtual threads. Let's profile again and see if there will be a difference. Yeah, not this. We want to go threads, monitor. Yeah. So it's a little bit better because most of our pool threads, our client threads are gone because we now have the pattern of our carrier threads. But there is still the problem on the server side that things are going into a blocking state eventually because the server is still spawning a lot of threads. Is there something we can do about this on the server side? And how? Yes, sure. What we can do on the server side is, remember our server Spring Boot and Tomcat, we can have a configuration class here, which is called Spring Tomcat Loom configuration. And what it will do, our Tomcat will now also get the task executor with new virtual per thread task executor. Basically the same thing we are using here on the client side. And with this, the configuration of the Tomcat changes. We see here we have a super secret flag, which is called Loom enabled for the server. Let's activate this. And let's see what happens. Ta-da! So suddenly we nearly have no threads at all. Of course, we have our 8 carrier threads from the client, and we have how many? I don't know, 1 or 2 on the server, and that's it. So with these 2 options, we massively scaled down the number of threads, and this is very, very nice. This does not mean that the system is running much more performantly. but at least the number of threads are massively reduced. And the nice thing is, we don't have to do anything at all. I will stop this. We just have to have this configuration class here, no, this here, and that's it. So that's already the end of the video. Thank you so much for joining me, and I hope to see you in the next video. Bye.